Hi everyone, it's a remake of the T2LT, the tuned transmission line trap antenna video this time. First one was a bit of a hastily created one, initially just intended for unlisted on YouTube, just so a particular person could see how it was constructed. They expressed an interest, so I made a video. It wasn't really intended for public viewing, but after a few more people asked, I just made it public, and it's been a fairly popular video, but a little bit below par because it was a bit shaky and the lighting was poor. Content's still okay, so no problem there, but just thought I'd have another go at it with a bit more background information. Anyway, it's proved to be quite a popular antenna. A lot of people have had some actually superb results with it, including myself. A few others really didn't like it at all. A bit of a love it or hate it antenna. Well, there we go. It's worth making one up and seeing how you get on with it, really. Simple thing to make, and really anyone that's got an interest in radio, really, or anyone that's wanting to do SHTF comms or something like that, it's always worth knowing how to make one antenna rather than having to buy manufactured stuff, because you never know when you might need to knock something up. So this one, centerford dipole, quarter wave ground plane antenna, what else, bazooka. They're all simple basic antennas, so I would recommend that you learn how to make one, learn how to make it well, and no doubt it'll serve you one in the future in some sort of emergency situation. So yeah, it's a good little thing to try, this particular T2LT. Very simple to make. Anyway, some people think that I actually designed the whole thing from scratch. I certainly didn't. I'm no antenna expert. The only thing I have done is take the sort of T2LT basic design and just marry that with the optimum choke as listed on the G3TXQ common mode choke chart. I've used that choke size on this sort of frequency of interest of mine, which is the CB band, and it's always proved to be a very effective choke indeed. So I just took that choke size, took the T2LT dimensions and construction, and just married the two together. So I'll just show you the various points of reference that I used for the antenna, so you can get a bit of background info, etc. So I'm no expert. There's argument out there whether the number of turns around the choke is important, whether the core size is important. I don't know. All I've gone by is this chart. So neither have the experience, the knowledge, or really the interest to delve into it too much. It's not really my area of interest, really. So first point of reference, G3TXQ common mode choke chart. Information at the top and bottom regarding the findings, but my area of interest, 26965 MHz to 27991 to 5 MHz. So that's bottom of the mid block to the top of the UK CB band. It's the legal CB frequencies in this country. So slap bang in the middle of that, we're virtually talking 27 megs to 28 megs. So right in the middle of that, center frequency is 27.5. So we just zoom in on this chart a little bit. See at the bottom, so you can use this antenna for whatever frequency you want. Just adjust the choke size and the dimensions of the antenna accordingly. 25, 26, 27.5. Green is the colour you want to be looking for. Deliberately not making this too mathematical, because I won't understand it, and a lot of people run away as soon as they see any sort of maths going on. We want to get as many people making these things as we can. So 5 turns RG213 on the 4 1/4 is pretty good. Then we got the thing there, 5 turns RG58 on a 4 1/4, which is what I will be doing. So there we are. That's the excuse me, optimum one for me. Scrolling up, there's various types of windings and ferrite cord chokes up there as well. So I know Jason 965 has used ferrite, and it's been great. So something from this chart for your choke and you'll be alright. Mine is that one, 5 turns, RG58 on a 4 1/4 inch air cord. In my case, bit of soil pipe, non-metallic. So that's that point of reference. Next one, we've got this. This is what I just googled for T2LT. German chap, and you'll see there's an alternative design there with a capacitor across the choke. That'd be a good one to try, but it is an extra component at the end of the day, and you're going to have to do some soldering and extra weatherproofing, etc, etc. By all means have an experiment, but for me that basic 5-turn choke has been doing the job. But probably for optimum tweaking, maybe look at that capacitor design, have a play if you so wish. Another design there. Then we have a very similar design to what I use, quarter wave, and the choke in this chap's case, if I can translate the German, which looks pretty easy, that's the ferrite being used as the choke with the coax feeder. So that's basically what we'll be doing. So some points of reference like that on the internet. And then last of all is a dipole calculator. Electrically, the T2LT is a dipole, a centre-fed dipole. It works on what's known as skin effect, so it's effectively 3 conductors, but that's one for another day. But it is a centre-fed dipole. So again, like I said, our centre frequency of interest, well, at least in my case, is 27.5 megahertz. There's loads of dipole calculators on the internet, or there's quite an easy formula you can follow to work it out, but like I said, I'm trying to keep the maths to a minimum because it scares people off. Zoom in on that bit of tricks there. This is G4NSJ site. Thank you very much, Mr. G4NSJ. And enter the frequency of megahertz, 27.5. Hit me. Total length of the thing, 17.02 feet, or 8.51 feet per side. That's 8.5 feet, 8'6", 102 inches. That's where I get the 102 inches from. So there we are. That's the other point of reference, and that's it. So literally now just move on to the next part of the video and show the component parts and see if we can knock an antenna up. So yeah, there we go. Good luck with it, and we'll catch you on the workbench. Right, into the construction side of things. Here's the component parts needed. Cable, in my case RG58, and it's RG58CU. I believe the C relates to the jacket material and the U is what they put on there to denote that it's stranded cable as opposed to a solid conductor. So indeed it's stranded for maximum flexibility in my sort of multi-deployment type environments. You can get away with solid conductor, but let's say for my sort of multi-deployment things where I'm rolling the thing up a couple of times a week and I'm rolling it, etc, etc, various temperatures, stranded seems to last. Solid conductor, no problem at all for fixed install, but in my case I use stranded. I have used solid and it worked. The actual dielectric on this one is a PE, I think it is, polyethylene, that probably stands for. It's a solid dielectric, again good crush resistance. There's no sort of air spacing going on that would get crushed and deformed in the sort of multi-deployment environments. And it's pretty cheap, but don't buy the really cheap stuff. Like I said before, if you strip it off and there's like a few wisps of copper as an excuse for a screen, then avoid that cable. This one is good quality cable. It's 95%, I think it is, braid coverage. I think I've actually seen a 98% braid coverage, but pretty decent stuff. That's what I've always used, and it's done me proud. A question I've been asked a couple of times: will RG8 Mini be suitable? You will be able to make an antenna out of RG8 Mini, but I don't know what to say as far as the effect it's going to have on the choke size. Excuse me. On that G3TXQ chart, he's used RG2L3. Good swig. Still recovering from a bit of a cough and a cold. He's used RG213, and he's also used RG58. RG8 Mini has got a different characteristic as much as the velocity of propagation value. Velocity factor is different. It differs. I think this is 0.66. RG8 Mini I think is 0.88. So it's got a different characteristic about it, which, not being an expert, but I would say could quite have an effect on how many turns you need on that choke for that choke to be effective. And with that choke being absolutely critical to this antenna, there we are. Might take some experimentation, or if you've got the kit to measure all this sort of stuff, it would be time to get it out if you're looking to make something out of RG8 Mini. In addition, RG8 Mini, I don't really use it much in my sort of type of activation, because it's got a foam dielectric. This is not PE, it's like a foamy type white stuff. Don't know what the actual material is. I find it's not very good crush resistance, and also it's not very good in cold environments. When it's really cold, or even just when you sort of work hard on it, that foam tends to break down a lot more quickly than this PE, so I don't use it. I'd use it for a base install, fit and forget, but not for the portable environments. I stick with a good quality RG58 unless the run is long, and then I use RG213. So there we are. I don't know. Anyway, moving on. Moves us on to the actual former. This is soil pipe, and I believe it's soil pipe that he's used in his chokes on G3 TXQ. Size 110mm, or indeed 4 1/4. Some guys have used golf hole inserts or something. Other people have just sort of made a cardboard former, wrap your cable round, and then dispense with the former, and this cable tie the actual choke to the right size, no problem. Some people have found a particular Coke bottle is the right size, whatever, but like we say, according to the old chart, 4 1/4 inches is what those readings, that chart's been based upon. So 4 1/4 is what I've always used, and 4 1/4 with the 5 turns has always proved to be a very effective choke for my actual frequency of interest. So there we are. Next component is PL259 plug, and I do actually pop a little ferrite in on as well, but I think that's, some people say yes, some people say no. There's been some argument which side of the choke it goes on. I've probably made a couple of antennas without one on at all, and I must admit I don't notice the difference, but I've got a load of them, so I tend to pop one on the radio side of the choke these days. So there we are. That's component parts. So all you need is some simple hand tools, and you can get on do a bit of construction. Okay, catch you in the next bit. Right, it's at this point where the actual construction can go in two different ways. The way I prefer, because it cuts down on actual joints and connections, etc., and makes the antenna a little bit more robust, is to measure from the end of the coax all the way down until you get to around about 106 inches. And then what I do, I just score around, score down the outer jacket, reveal 106 inches of the braid, just nip it off without catching the dielectric, take that braid away, exposing 106 inches of dielectric. 106 inches, a few inches extra for SWR tuning. But what you can do, it's probably a simpler way of doing it, and it will save you a little bit of coax. You can, at this point, just strip off a little bit of the coax, give that a bit of a haircut, and then what you can do then is just literally put like a chop block electrical connector or solder it or whatever, and you can put your 106 odd inches of whatever insulated cable you want. So it could be a bit of speaker wire, could be a bit of electrical wire, whatever. But like I say, it does just introduce that little, perhaps, extra point of potential failure. But by all means, go with that design, but the rest of it is the same. But for this particular video, I'm going to be doing my normal method of stripping back the outer jacket and braid. Okay, catch you in the next bit. Right, what I've now done is, from the end of the cable, measured 106 inches down. Seems a long way, but it's right. There we are. I marked it with a little bit of tape, 106 inches from the end. And what you want to do now is take your craft knife, your Stanley knife, or whatever knife, just score around the outer jacket. Doesn't really matter if you cut into the braid slightly, but what you certainly don't want to do is cut into that centre dielectric. And just sort of bend the cable against itself there, and just, if it's in the shot, you'll see it just exposing that dielectric, that braid I should say, like so. Then what you do, you can sort of, you can see that, place that knife on the actual cable itself, and then literally just sort of, it's a job to show you actually, show you ass about face, it's back to front. The finger is on one side touching the board, my thumb is on the other side touching the board, to give it a good sort of stable platform. So as you can see, that's vice versa now. Job to show you. Could do an assistant on the camera really. And then just draw that cable through, and it's just, it doesn't have to cut all the way through, just scores it, a heavy score on the jacket. Draw through, draw it through, draw it through, draw it through, all the way. Be very careful with this obviously. Doesn't matter if it goes wrong a bit, as long as it's you get the jacket off at the end of the day. Draw it through, draw it through, all the way. The end is in sight. Drawing it through. To the end. There we are. So you should see your little score in the cable. Just part that like so. As you can see, it comes away easily. pull it all the way off, all the way off, all the way off. Till it's gone. Now this is where again you could go with a bazooka type antenna here. You could do that lark where just balloon out the braid, relax the braid, and then fold it over and make a bazooka like in one of my other videos, but we're not making one of them today. So all I'm going to do is relax that dielectric, or relax the braid from the dielectric. Does it easy. Might want to have a practice trying to get it to fold over, but you don't need it for the T2LT. Some people think it's a braid fold over antenna. It's not. That's that bazooka thing we did. Perhaps they call it a sleeve dipole. So just relax that braid off of the centre dielectric all the way down. Just relaxing it. Takes a bit of fiddling around, but go to the end a couple of times. Just relax it off. Nearly there. Like so. And just with a pair of scissors or a pair of snips, just get in amongst it. Whatever you don't damage that centre dielectric. Just get in amongst it. Do a bit of a haircut all the way around. Decent pair of scissors would help. Nearly there, just hanging on by a thread. There we are. It's as free as a bird. You just pull that out of the cable. So that's now the braid that we don't need anymore. So now we've got that 106 inches exposed, and what we'll need to do now is measure 102 inches and then we'll start the coil. Catch you in the next bit. Right, without much further ado, just a little drawing there of what we're actually doing. So what we did in the last part of the video is just expose 106 inches of centre dielectric. It's 106 inches because of a little bit extra for SWR tuning. 106 inches, that's where you hit the outer jacket. Then 102 inches, I'll make another mark, then we'll wind the choke. So I'm going to get on and do that. You can see there's the point that the dielectric meets the rest of the cable. So without further ado, I'll make that measurement and wind the choke. Right, moving on, time to wind the choke. The green and yellow tape there equates to that point on the drawing. Blue tape's just there to hold the cable in place momentarily. So I tend just to, rather than just wrap the cable around in a rush, I sort of make it sort of want to go on the former, so it's not sort of fighting against itself. So just hold it a little bit further down and just introduce a twist. Just twist it like that, look, so it wants to go in the right direction. And there you've introduced a turn on your former. So I'll carry on and do that until I've got my 5 turns. And then we're pretty much there apart from putting the PL259 on. Okay, catch you in a bit. Okay, plenty of videos out there on put PL259s on, so I won't go into that. One thing I would say, I favour this crimp stroke solder the centre pin. The outside, the braid, I like the way it deals with the braid. Basically what you've got is a collar that comes over that braid. Just a little bit hot. Just goes over that braid, and then you crimp it. Obviously with the correct crimp tool. Not a pair of pliers, that makes for a crap job. Crimp it. Crimp it. A little bit of tidy up any sticking out braid there. And that deals with the braid nicely. There's an age-old argument that goes on the forums and on the internet. Solder the braid or don't solder the braid through the holes on a standard PL259. Some people say they've never soldered it in their lives and it's great. Some people say always solder it. This way it's all dealt with nicely. I've been using these crimp-on connections for all the outdoor activities now or anything, bass installs, everything, for probably 5 years now. Not had a single failure. So that says it all really. So we are. PL259 is on. A little bit of tidying up, a little bit of testing, and a little bit of tuning. Right, now time for a little bit of basic continuity testing. Very basic meter I've got there. They're only about a £5, well worth the investment. You could use a battery and a light bulb or a little buzzer type continuity tester for this purpose. No matter. Quite simply, it's on the resistance setting, and when you touch the probes together you get full scale deflection, and when they're apart you get no deflection. So when something's got continuity, it's that. When there's no continuity, it's that. So first up, zoom out a little bit. There's our PL259 by the choke there. We'll just check whether we've got a short across that. If we have got a short, that's bad. Right, holding one probe on the outer shell, the other probe on the inner pin. We have absolutely no deflection at all, showing it's open circuit, as in no continuity. So that's good, so that shows we've got a dead short across the antenna. Next test, and this is deliberately done before I've done the last little bit of finishing off, as in the weatherproofing. At that point where the centre dielectric is exposed, a little bit of braid we can get to there. So again, hold a probe on that, and then from the outer shell of the PL259 we have full deflection, which means we've got continuity to that point, which is correct. So far so good. Last test, just pull around the table leg here. I've exposed a little bit of the centre conductor there on the end of the dielectric. Again, we'll hold a test probe on that. Let's put it on there for easy's sake, and then we just hold the, we'll just put the other test probe on the centre pin of the PL259, and we've got full deflection. So that shows we've got continuity there too, which is correct. And just to double check, no deflection on the outer shell, which we've already proved in the first test, which is indeed correct again. So that could well save a bit of mucking about, because there'd be certainly no point in trying to SWR an antenna that's got a short across it, or has got a lack of continuity to either the braid or the centre conductor. Obviously you might have a flaky or dodgy connection, but at least that basic test proves that there is indeed hope for this antenna. Okay, time for a little bit of tidying up in the middle there, and then this antenna is going to be ready to take out and tune. Right, last part of the construction phase is just a little bit of tidying up where that dielectric and the braid outer jacket meet, just to keep any wet out. So I've just put a bit of self-amalgamating tape underneath there, and then a bit of heat shrink on top. Probably not strictly necessary, self-amalgamating to do the job, but just tidies it up nicely. And there we go. So that is done. The antenna's constructed. So next thing is to take it outside, and we'll see if it'll achieve a decent SWR.